lecture is going to be about studios and the construction and components of studios. The main things in studios to consider in construction is acoustic isolation, the frequency balance, acoustic separation, reverberation, and cost. Acoustic isolation is keeping sound from outside from bleeding into the studio so that you don't record things that you're not trying to record, such as noises in the outside, cars, airplanes, gardeners, things like that. The frequency balance is about keeping the sound as true as it was in the studio into the recording. So, for example, if you put a bucket over your head and recorded, you would sound different. Those types of things you want to keep out of the studio. So the studio would have to be balanced. Acoustic separation is keeping sound into the microphone that you intended. An example of that is if you had drums and a vocalist in the same space, you want acoustic separation between those if you're recording at the same time in order to mix those properly. Reverberation is the sound in the room, so the bigger the room, the more reverberation you're going to have. The smaller the room, the less reverberation. And then the cost. The project studios are the main studios today. And basically you're constrained by the type of building you're in, where it's located, the dimensions of the room, and the materials in the room, the floor, for example, and how much cost you want to put into it. But project studios are great, and you can see in this picture, you can put up sound panels on the walls and isolate the sound that you're recording and work in a project studio. Most musicians now have project studios because it is very convenient and cost effective. Commercial studios are a place of business, so you're talking about a totally different thing where usually you're renting a space and building a large studio with a large mixing console. You have a place for clients to come in. So, for example, a lobby or an office. You have a space to store equipment such as microphone stands, cables, and you'll usually have 2 rooms, one being a control room where you're going to be operating the mixing console, and another space for recording. So let's talk about acoustic isolation. It's an interesting concept as an engineer to understand acoustic isolation, and there's a formula for calculating it. What it means is it's all about the transmission loss through a material, and that equation depends on the surface density of the material. So in other words, the thicker the material or the surface density, the better it is to isolate 2 sounds from each other. And there's some values I just wanted to show you as an example. Pull those up. Here we go. So an example would be concrete. It's very, very thick concrete would have a very high surface density. There's another example. Sand is good. It has a lower surface density, but you can pull up surface densities of different materials. Usually people use panels in between instruments or heavy blankets, and those act as real good dampening materials. So one trick is to put a moving blanket or a big blanket on a mic stand that's set up horizontally, and then put that in between musicians. So some room considerations are your walls, floors, ceilings, windows, and doors, and isolation booths. So for walls, it's common to use sound panels. I use 4x6 panels that I got at a music store, and I just glued them onto 4x6. Basically, it's sound isolating cardboard from Home Depot, and then I can nail those to my walls. That's an inexpensive fix for walls in a home studio. Floors, you might consider carpet or removable carpet. Usually in a small space, the floors are pretty live, and it would be something where you couldn't control the sound if it was just all wood. Ceilings, if you have a low ceiling, you may need some sound isolation, but usually people leave ceilings alone. On a bottom story, it helps if the top story is carpeted above you, just to isolate the sound from there. Windows and doors. Sometimes windows are a big problem, but you can also put foam and get foam and just temporarily put it in front of a window or inside of a window in order to isolate this sound as much as possible from outside. And isolation rooms are amazing. You go in there and the sound is dead, and you can record everything in an isolation room and then add reverb to it later. That's a very common thing that you'll see, especially if you're at a school, that most schools with the sound program will have an isolation room or isolation booth. In a bigger studio, you'll have isolation rooms for each instrument if you want to record that way. So drums would be in one room, vocals would be in another room, for example. Okay, so another thing in a room is you want to keep the sound as true as possible, and that has to do with frequency balance. Basically, if you're recording in like close to a wall or a corner, or there's things in the room causing a problem, you'd want to look at the frequency balance of that room, and then reorganize things in order to have the sound basically record the same way it sounded in the studio. Absorption, there's high frequency absorption and low frequency absorption. So high frequency dense porous materials like cloth fiber, glass, and carpeting are important. Those are high frequencies, for example, coming from cymbals or high frequency pitched instruments. Low frequency absorption is pliable materials. There's a picture here of bass traps that go in the corners of the room. Those are really important to keep bass in. So those are like kick drums and bass guitars. The bass frequencies, being long sine waves we talked about in the last lecture, those tend to bleed in and out of the room. Another good example is garbage trucks or a blower from a gardener, sometimes airplanes, all of those things. So low frequency absorption, if you have bass traps in the corners, will take care of that sound that you want to keep into your recording. Reverberation is basically the sound of the room. So for example, in a movie studio, you'd have a giant large room made out of concrete like they do at Sony in LA, and you get the sound of the room. You get a nice reverb, airy sound in there. So rooms are built to have a certain sound. And you can calculate the reverberation of a room. It has three components: the direct sound coming from the source, early reflections, which are bouncing off the walls, and then the reverb, the time it takes after those reflections in order for the sound to decay. And there's also a formula of that for that. RT60 equals the voltage times 0.049 over the area and the surface area in the room. And you can calculate, which engineers do, a reverb in a room before you build it. And finally, let me talk about power conditioners for a minute. Power conditioners are a lifesaver. In fact, this week when I'm recording this lecture, we've had high winds and storms, lightning storms, and I've lost my power 3 times to my computer. And my power conditioner saved all my equipment. So I have all of my sound recording equipment and my computer plugged into a sound conditioner. It regulates the voltage. It keeps everything quiet as far as the electrical lines, and it eliminates power interruptions. Also, in a large power surge like a lightning strike, it'll handle that voltage variation and turn off your equipment without damaging it. So it has saved me a couple of times just this week. So it's important in a studio to use a power conditioner, Furman being the main manufacturer of power conditioners, and so I have a picture of a Furman here. So I want to show now a couple pictures of some ways that studios are built. A lot of times when you have a large concrete area and you're building a studio, it's built with a false floor and false walls so that you can control the space. So here's a picture of floor of treatments on the walls, and then a raised floor and a false walls. And so it's basically a room within a room. Here's a picture of transmission loss, where you get the sound and the sound reflected sound, and then anything that goes through this barrier is a transmission loss. So this sound would be bleeding through to another space. I love this one. This is how I built my studio. I built walls that are offset. They're offsetting the studs, and in between there's filling made out of fiberglass, and this adds it's an uncoupled design, and it adds soundproofing to your room. So I was lucky to be able to build a studio from scratch and have the walls done this way. They're very quiet. Here's a picture of some flooring, a floating floor where there's fiberglass and then plywood and then plastic and then concrete. But in my studio, I just have a concrete floor and then carpet over that, and that seems to work pretty good. That's how most people would have their home studios. And here's another way to do it. Flooring, padding, plywood, padding, carpet. It's basically isolating your sound from the original floor, if that's necessary. This is another thing that is very common. It's called a Z-brace. It's basically hanging a false ceiling from the original ceiling so that you can control the sound from outside. And here's a door design. Door designs basically are, in a commercial studio, they can get quite expensive, but they're usually heavy doors, and they allow the sound to stay in the studio and isolate the sound from outside. And those also isolation booths are designed that way. They're not heavy doors, but they're insulated doors that trap the sound inside. And here's a picture of a commercial studio with some isolation rooms. That's pretty typical. If you need to record in a bigger space, that's a typical setup. And then here's a singer in an isolation room, isolated from the mixing side or the control room. And this is pretty common in a school space where you have sound panels around an instrument, around a singer, so that isolates that sound so that you get the true sound in the microphone and the recording. Also, this is good when you're recording people in the same room to put something like this around each player. Here's the example I was talking about, using a microphone stand and a blanket or a moving blanket. You can use that in between players, and that adds that isolation in between instruments and keeps the sound in the microphone that you're trying to capture. And here's a couple pictures of setups for a mixing space where you always want to have a balanced space so you don't have different frequency responses. So this is similar to my setup where I'm facing the room, and then the speakers are equidistant from your ears and the walls. You can also do it in a corner this way, as long as the speakers in your ears are equidistant from the walls. You wouldn't want to do an offset. This is where you're getting the wrong frequencies and where you're on one side of very close to one wall and farther away from another. And then here, also for frequency balance, if you're using monitors, it's good to have them on a stand or if they're on a desk. This is an Orlex pad where it isolates the sound of the speaker from the desk. And here's some pictures of some wall treatments where you can use a diffuser or panels to balance out the frequencies in a room. There's some more of the same. And these are, if you're in engineering, these are in frequencies, absorption coefficients for various materials. So how well the absorbed sound. You can see, compare like carpet, heavy carpet coefficients in here versus like glass or concrete. And then here's a picture of some absorption materials and bass traps that people use in a room, and then here's a room using all of those types of things. So that would be a great recording space where you've got everything is in the same room, but it's all isolated here, so you can record vocals, guitars, things like that in that room. And then finally, for low frequencies, there's bass traps where you have sound that you need to absorb so that it stays in the recording. And here's some more bass traps. So that's a little bit about studios. Main thing is you want to make sure that you're designing a space, that you're recording what you intend to record. It sounds like it did in the studio. You're not getting things in a microphone that you don't want. For example, vocals, you don't want a lot of drums in that vocal, or you won't be able to mix it. You're within your budget, and you're within the budget for the types of projects and the income that you're going to get from those projects. So that's a little bit about studio construction and the types of things to consider. The main thing is make sure you're in a space that's quiet, that you can control the sound in the microphones, that you can separate sounds from one source to another source, and that everything sounds, each track, how you intended it to sound during the recording. So it shouldn't sound completely different in your computer or in your recording device as it did during the actual recording session.